the very first library, which is NumPy, which is it stands for numerical Python, numerical Python library. So if you, and again, the libraries that we are going to discuss today is NumPy, Pandas, and Matplotlib. So numerical Python is because if you want to do any numerical calculations that involves mathematical standard equations or mathematical functions that you want to do, instead of you writing it from the scratch in Python, the community, the library had already taken care of building arrays for you and building those mathematical functions for you, and made your life easy. So you just import it and then use it as per your name. That is with the numerical Python. The next one is Pandas, which stands for Python panel data sets. So they are, the library Pandas is almost everything that we deal with the tables. So with the data frames and series and arrays. So from Pandas library, we can import any CSV files or Excel sheets and do any data analysis on top of that also, if you can learn this. And on top of that, these Pandas are going to be useful for you to play with electrical table sets as well. So that's going to be a very important library. And then third one is Matplotlib to do any part of visualization on top of uh, any library. It can be NumPy or Pandas. If you want to do visualize it in terms of graphs, mathematical graphs, it can be a bar chart, pie chart, or a scatter graph, and or a linear regression graph. So we can plot those graphs using Matplotlib library. And there are other libraries like Seaborn Lab and Plotly libraries. You can also learn, you can also adapt learning those things. But again, these are the minimum basic requirements that we need to have before we move on to the next day 4 or day 5. So I hope these three libraries will be completely hands on for you, and I will request you to simultaneously do if possible. But I'm right now sharing the link of today's collab file in the Google chat, so please try to access it. You can just refresh my page, it will directly be available for you. So I'm pasting it in the Google chat. So yeah, we'll get started with numerical Python. So the NumPy, always you can see that it stands for numerical Python. So if you ask me a question, the new NumPy library almost revolves around the arrays, which is nothing but list. So if you remember, we discussed data type list in Python programming, where a list is nothing but a collection of items or collection of elements, collection of multiple values in one square bracket representation is what we learned, right? So similarly, I even told that there is something called an array, which is not completely same as an array in other languages, but there is a difference in Python. That exact difference is what we are going to discuss today. So array in Python is coming under NumPy library. List in Python is just a data type in it. So array in other languages is a different different uh, actions altogether. So I suggest you to never compare arrays in other languages to the Python array or Python list. There are differences. So now moving on, uh, if you ask me why array concept when you already have list, what are the differences to the existing list concept in Python and array concept in NumPy is, if you remember when I told about the list, I hope you can see the Jamboard as well. So if you see a list consists of multiple numbers like this, 1, 2, or and so on. If these are the items or elements of a list, so usually list saves these items one after another in adjacent memory locations. That is the very first factor. Second factor is you can use any data type as an item inside this list. You can either write a number, or you can write a string, or you can write a complex number, or you can write a sub list, or you can write a tuple, or you can write a dictionary, or you can write a set. So any item is allowed to be an item inside a list. But when it comes to array, it can only have homogeneous data type. It means the data type of the item or the element that you are going to assign in this array should be unique, unlike the list. So, and the data structures, it means internally array uses linked list and other data structure concepts to make this more efficient and easily accessible compared to the list concept in the Python. So these are going to be your key differences. I'm going to show you the example of a list and then array and what are the differences in the Google Colab. But yeah, this is going to be the key differences. So if you see here, if I just take a list like this and confirm that it is a list. So I hope you already know how do we confirm the data type of this. It is type of A. It's a list. How do we create an array in Python? That is where we will be using, by default, NumPy array is not going to be in your kernel, in this case in your IDE. So if you want to use it, you have to enable it or you have to import it. So the syntax to import something, any library, is the keyword import, and then you have to specify the library that you are trying to import. So NumPy is a library that I'm trying to import, and then as stands to the alias. It means whenever I want to use the library NumPy, I don't need to call the word NumPy. Instead, I can keep an alternative, something called NP. So NP is just like a shortcut form to the NumPy. So whenever I say NP, it's nothing but it is referring back to the NumPy. So we will be importing NumPy here. So now it will allow us to use this NP keyword as an importing library anywhere when you apply in this throughout this Collab notebook. So now let me try to create an array for you. So the way to create an array is np dot a method array, and here is what you can give the input. In my case, let me give the same thing. Whenever you get these suggestions, I said you can press escape key. It will avoid that auto suggestion. So now let us try to run this. So array of 1, 2. So this is a list and this is a NumPy array. So the difference again, right now, if you see my data types of the items is just a number here, and here also it's a number here. And if I try to keep a string in this, let's say hi here, and then let's try to give a sub list in this 1, 2, something like this, and let's try to run this. So let me also print the list along with my type. So I can do print a type of A. So A is nothing but this, and the data type belongs to the list, which is a class. So you don't need to worry about class right now. This is a oops concept. It is just trying to be accurate to show you that the data type belongs to this class. So don't mind about this class. It is nothing but being accurate with respect to data structure, oops level. All right, so now np.array is this. So what is the confirmation? Again, if you see, if I include a string in this, let's say some 45 is a string again, and let me give another string, something like this, and try to array. So you see this, even though I gave numeric data types as an element here, still it gave me an input as a string. So it automatically converted my numeric data type element to the string. Why is it happening so? So in the concepts of higher order data types and lower order data types, the integer, the float, and then the complex, and then the string, this is the order that we have to follow in terms of the lower order to higher order. So the higher data types, data types are strings, again, list, tuple, all those going to be coming under sequence data type. But if anybody asks you any sequential order when it comes to data types, so the integer comes the very first preference, and then next preference goes to float, and then goes to strings. Right now the higher data type is string. So even if one element is of string data type in this entire array, it will convert entire elements to string. So if you want to see that again, so let's only take a simple numbers like this. So right now, all my data types of the items that I use in this array are numbers. So it's going to be just a number. And if I want to use a string in top of this, let's say if I even convert one element to string, it will convert all of that to string. So instead of string, let's say I give a float value. When it comes to 44.5, it's a float, right? So if I run this, you see that it converts even the integer data type to float. So here float is going to be the higher data type compared to a simple integer. So 1 and 2 are integers. As there is a float value as an item in this entire array, it converted even previous ones to float. So that's how differently it is with respect to the list. So this confirms that the NumPy array is a homogeneous, not heterogeneous. So lists are heterogeneous data type items allowed. This is a homogeneous data type items allowed. That is with NumPy array. And moving on, what else we can do with NumPy array? We can store this NumPy array in some variable, which is like this. Let's say I give A and B and C and D. This is one of my examples to array. Let me try to print it. Good practice is to use print function. It printed my NumPy array. Again, what is the confirmation that it is an array? You can see that the type of A here is going to be the type of A is going to be the NumPy n-dimensional array. So the difference again for the list is it's a list. For NumPy array, it is going to show you NumPy n-dimensional array. So whenever I'm using this dot, it means from the NumPy library, I am making use of array function or a method, right? So now it says that there is something called n-dimensional array. ND stands for n, D stands for dimensional. So n-dimensional array. It means that there are dimensions involved within this array, right? So 0 dimensions is obviously, you must be aware that it's a scalar, right? So 0 dimensions is a scalar value mathematically speaking. Again, whenever people say scalar, you must be aware that it's just a value magnitude without any direction, which consists of only magnitude. So the one dimension thing is nothing but a vector, which is nothing but represented using array in our case. So arrays are going to be our vectors, which consists of magnitude and direction. You can apply matrices, or you can apply vector algebra kind of calculations, mathematical calculations, or you can apply linear algebra calculations using these kind of array representations. All right. So now 2 dimension is a matrix. A matrix is nothing but a combination of multiple arrays, which is a 2 dimension, right? So combination of multiple arrays, and the 3 dimension or more belongs to tensor. This is where you can see that it is going and relating to the machine learning libraries there, which is a famous library out there is a TensorFlow, which is again on top of multiple dimensional arrays like this. So TensorFlow literally works on these things. Anyways, the concept is about NumPy, so let's stick back to it. So now that we know which dimension is which, I've been defining the simple array that is 1 dimensional array. So 0 dimension is nothing but a simple integer, and this array is nothing but my vector. This is the way we can represent a vector. If I want to create a matrix, you just give multiple of these arrays, it becomes a matrix. So before we go on to matrices or seeing those multiple things, let me also show you multiple ways of defining an array, just not like this. So for example, I have a list like this. Let's say I have 5, 6, 7, 8. So this is a list, and I want to convert this list input to an array. So what I would like to do is np dot array of a. So all the values that are there inside a will become type converted to array. So this is how the array becomes. This is one way of defining an array, and another way of doing it is you having a range function. np.array is one function, so you also have a range function which will allow you to give a range to this. Again, dating back or tracing back to our first concept in slicing or indexing in the data types of Python, it also follows the same as range function. The syntax for this is going to be start value, stop value, and step value. So it remains same here as well. If you had learnt it once there, the same concept will be applied throughout this libraries and all over the Python. So in my case, I would like to generate an array which starts from 1 and ends at 10. As you remember, 10 is usually considered as excluded part, right? So let us see now. So it generated an array from 1 till 9 excluding 10, because the second parameter is standing for end value, and as you remember, end value will always be excluded. So now let's say I would like to create another array, np dot range of let's say 1 to 50 with a step value of 2. You do see that it generated an array of elements from 1 to 50 excluded, which is like till 49 with the step value of 2. It means it starts from 1 and 1 plus 2 is always a 3. And then 3 plus 2, 5 plus 2, 7 plus 2, 9, and so on till the range that you specified in the end, which is exclude. So this is how you can generate an immediate array if you have this logic enabled. So that's how you can do with a range function. Or similarly, if you want to build a matrix of this, let me take this function and put it in a variable. As I said, a matrix is nothing but a two-dimensional thing. So one square bracket in a shortcut way, this is just like a mind mapping. If you have one square bracket, it means just single array. It means a vector. So if I have to build a matrix on top of this, let me take an arrange function to build an array and put it in a variable like this. Let me confirm what it is typing. So it is going to generate an array from 1 to 9 excluding 10. Similarly, I'll create one more array, np.arrange of, this time let's build from 11 to 20, and let us also confirm the existence of b. So it generates from 11 to 19. Now that we got two different arrays, I would like to build a matrix on top of this. As I said, a matrix is nothing but a two-dimensional thing. So matrix will have two dimensions, since two different inputs. So now let me keep this a and b as an items to one single array. So whenever I say an array, we will keep one square bracket which represents a one dimension. Internal to this, we will give values a comma b, and let us try to see this representation. Yes, this is how it looks like. So now it means it is a two-dimensional array, which means this is a matrix. In generally, we will represent a matrix to the students or outside with a longer bracket like this, and we represent a matrix like this. In Python programming and while typing it, we will be representing with the square brackets in this way. All right, so that is how you can also generate a matrix. A matrix, again, you can have any number of shape. Usually matrix is considering a considerable number of rows and considerable number of columns, right? So if you want to check the size, even that is also possible in here. So in order to check that, you can just check size here. So in my case, this is the matrix. So let me name this matrix as C. So C becomes my matrix. Let me type C and then confirm again. Using A and B values, A and B arrays, I built a matrix. Now C is this. Let me apply something called size on top of my C. You do see that there are 18 elements. If you want to confirm it, let me put this in a different cell and see the differences. Let me print C here. Let us see the size of the matrix. This is 18. So why is it 18? You can see that it is 1 to 9 and 9 to 2, it is 18. So these are any number of elements. And if you want to see C dot n dimension, it is telling you that this array C, this variable C consists of a two-dimensional matrix. So it is a two-dimension. This is how you can check in which dimension that particular array or that particular variable is having. All right, so this is one way, and you can also see the order of the matrix with C dot shape. which will let you know that there are 2 rows and 9 columns. So this is a function where it will be used to see the shape of the matrix. And again, you do know that there are transposes and there are a lot of matrix calculations that we can apply. All those can be applied in this numerical Python as well. So in my case, if you observe, there are 2 rows and 9 columns, which makes that 2 into 9 is nothing but 18 elements. What are the shapes that I can also try with respect to 18 elements? If you see, what are the other shapes or other dimensions that I can try with 18 elements? So 2 comma 9 is like 2 rows and 9 columns. Obviously, it makes up to 18. So it's just like we are finding out other shape is nothing but other factors of 18. So what are the factors that it can be? 2 into 9 is already done. So it can be a 2 by 9 matrix, or it can be a 3 into 6 matrix, which makes it 18 again, or it can be a 6 by 3 matrix, which makes it 18 again, or it can be a 9 by 2 matrix, which means 9 rows 2 columns, or it can be a 18 by 1 matrix. So these are the possibilities of these matrices. If you want to cross check it, you can try on one matrix like this: c dot reshape. Currently my c shape is looking like 2 by 9, so let me convert that to 3 by 6. So let me reshape it with 3 comma 6 and try this. You do see here, before shaping it out, it was 2 by 9 like this, and it became 3 by 6 like this. It means 3 rows and 6 columns. So this is how you can reshape your columns as well. All right, so that is your n dimension thing. Or now that you are a 3-dimensional matrix, I want to bring this to back to 1-dimensional array. So that is exactly where you can apply. Now let me store this array in one variable, let's say d in this case, and run this. So d is my variable like this, and I would like to, let's say, I would like to bring this back to my 1 dimension. You can apply a direct function called flatten, which will bring back your 2-dimensional vector to a single dimensional array. 2-dimensional matrix. I apologize for the vector. This is 3 by 6 matrix, which is a 2-dimension. How did you say it's a 2-dimension? This is the shortcut you can remember, or you can apply dot endem function on top of it. So in this case, reshape did me 3 rows and 6 columns, and I used flatten on top of it, which reduced it to a single dimension. You see that there is a single bracket. This is how you reduce from one dimension to another dimensions. All right, so again, what are the other ways of shortcut ways of generating arrays? So Python, numerical Python provides you numerous functions in that way. So you can try np dot once. If you specify a number like this, np is again the shortcut that we all agreed upon while importing the NumPy library. See, this is why I'm not writing NumPy all the time, and I'm applying once function on top of NumPy library. So what I'm saying with this function is, I'm asking my NumPy library to generate 6 ones as an array. So it generates an element, 6-element array. If I want 10 elements, it will give me 10 elements in one array. So it is just one dot means it's just trying to be accurate in float values. So this is how you can generate ones, or simultaneously you can generate multiple dimensions with only having ones. Again, once in a matrix, all the elements as one is nothing but a unit matrix. So in my case, let me try to generate a 3 by 3 matrix. Let's give one more function input. So it generates 3 rows and 3 columns, one all our numbers as ones, because the method that I'm applying is ones. Simultaneously, you also have zeros as a function, which will reduce your burden. So it will generate an array of all as zeros, and simultaneously you can generate a null matrix with zeros. So not just zeros and ones. Now that you got it out, can we only do ones and zeros? Can we not do other numbers? You can also do it with full function, which will allow you to keep any customized number that you want to do with respect to matrix. So in your case, you can fill the number, let's say 3 for 3 times. So it will generate number 3 with 3 elements in that array. Let's say you want number 3, let's say 10. what it does is three tens. So if you want a number, let's say seven tens, will give you a array which has seven tens in this. So this is how you can do. Also apply dot full. You can generate, let's say, 8, comma 8. Will just give you 8 eights. So this is a shortcut way of doing uh, customize the generation of the inputs. All right. So on top of this, you must also know about the slicing concepts. Again, the slicing in NumPy array is not so different to the slicing concept which is in Python. It is absolutely the same. This is exactly why I said if you learn it once, it is applied on all over the Python program. So let me try to take an example. In this case, let me take this. I'm making use of this concept. Let me apply this. If you see here, my matrix looks like this. In this, I would like to access only, let's say I only want to access 1 to 11 12, not all the elements, just 1 2 and 11 12. So the syntax for slicing is, again, you can use np dot array. In this case, you already have that created, so you can just say, see, if I print, see, it is giving me this. If you apply the slicing on top of it, let's put like this and run it. So you do understand that I did not mention when to start and I did not mention when to stop. It means to find those problems. Yeah, it means you are not saying it when to start and when to stop. So it is by default taking all of them as, for the consideration. Let's say you have a considerable, let's say, a condition like this and run it. So what it will do is, let me even give 7 to 7 and 1 colon 2. Okay. This is for rows and this is for columns. Let me just say till 4th column. So what you see in this is the very first syntax is for the rows. So maybe if you want it as a general syntax, let me write it on top of it. It will be easier for you. So this is like start row colon and you can say end row for rows, comma, and the start column colon end column. And you can also write step here, so which we will avoid it right now. Reduce the complexity. So if you see here, I left this empty. When it comes to rows, it means I'm literally asking it to print all the rows available. But here I am telling nothing in the start column. It means starts from very first column itself. If you leave it nothing, if you leave it with nothing, it will just start from by default the very starting one. Fourth means it will go up to 4th column. So if you see here, 1 2 3 4, it's the 4th column. If you want specially let's say 2nd column to 4th column, this is how you can access. If you see here, it is, again, why it is going from 2, you remember the indexing concept. This is 0th column, 1st column and 2nd column. So this is exactly why 2 colon 4 means it is taking from 3 and then this is 3. If you remember, 0 1 2 3 4, 4 always is an end value. End value is always excluded. That is exactly why it is starting from 2nd index position, goes till 3rd column, because 4th column is an end value and it always excludes the end column or end values. So this is how you can access a sub part of one matrix. All right, so you can now play with, you create your own matrices and you can play with these positions. You can try to access any part of this. That is how accessing sub part of the matrices happen. And if you want to generate a line space, there is a line space for it. What does it mean? Let's say I want to generate equidistant points from 1 to 10. Let us see, run this right now. If you see here, it is trying to give me a minimum, which is a default value. It is trying to give me 50 equidistant values ranging from 1 to 10. These are equidistant values from 1 to 10. It means I did not specify how many points I want here, so it is by default giving me 50. What if I give 5 points? What does this mean? I want a range from between 1 to 10, 5 equidistant points. So let us see what does it generate for us. If you observe carefully, from 1 to 10, 1 to 3.25, then 5.5, 7.75, and then 10. These are the equidistant points. So if you see this, the difference between this point to this point and this point will be same. And then this point to this point. So these are the equidistant points from one another. Let's say I want to generate line space. Let's imagine I want to generate, let's say from 10 to 20, 3 points, which are equidistant to each other. It starts from 10 and then 20. So it asked 3 point. We asked three equidistant points ranging from 10 to 20. So 10, 15, 20 are the three equidistant points, right? 10 to 15 is 5, 20, 15 is 5. So these are the three equidistant points. This is how you can generate a line space arrays with equidistant points. This will be very much useful in comes to electricals when you want to generate line spaces. So that is this. And I think there are other functions, mathematical functions like square root and sort, all of that. They are very simple for you. I think it's like if you have an array like this. Let me take an example of this. I don't want a range. Let me take an array and write 1, 3, 5, 8, 9, randomly some numbers. So this is an example of an array. Now what I would like to do is, let us try to apply few mathematical arithmetic operations on top of these arrays. So if this is my A array, and if I do let's say square root on top of this, sqrt is a function for the square root in regular way. So if you run this, it will show you a value after applying square root on top of each and every element of it. So square root of 1 and square root of 3, square root of 5, square root of 8. If you just mention single variable like this, it will apply on each and every element of that array. So this is how the square root function works on it. Or if you write a plus a, so I'm just moving to arithmetic operations. Let us see what does it give. So if you remember, if you observe it carefully here, it added array to another array. In this case, I'm adding two same arrays. So 1 plus 1 is 2, 3 plus 3 is 6, 5 plus 5 is 10, 8 plus 8 is 16, and so on. This is how arithmetic operations will be applied on top of each and every element of that array. So you don't need to specifically tell for each and every element like this. Just apply this. By default, it will take on each and every element. So that's one way of applying functions on it. Again, if you want to do some, let's say, comparison operations, let me take the same example of array. What I'm going to do is, I would like to access elements which are greater than 10 from this array. I only want elements which are greater than 10. So if you do a greater than 10, by the logic of previous one, if you remember, when I did square root, it applied on each and every element. When I did this, it added element wise addition. So this element position to this element. Right now I added to itself. So the dimension and the length of the array remained the same, and it added element to element. If you give a different length of the array, it will not do that element wise addition. What I mean to say is, if my A is this and B is having something like this, I cannot add A array to B array. It is because the dimension, not just dimension, the length of this array is different to this, and there will be incompatibility. So you can never apply element wise things with incompatibilities. So now similarly, when I apply a greater than 10, it will try to go and compare each and every element of this array and see what does it give. See there, it is giving you the Boolean outputs after applying this condition on top of comparing with each and every element of that array. So whenever it is true, it is giving us true. Whenever it is false, it is giving us false. So now what I'm going to apply is, on top of this logic, I want elements only when there is true function, I mean not function, a true boolean case. So what I will do is a of the condition that I want to apply is a greater than 10. You see, the only values which are greater than 10 will be considered and will give you an apply. This is how you can apply any condition or an expression on top of an array. Like this, you can apply less than, you can apply greater than, you can apply comparison operator, double equality, or you can apply a expression on top of this. So everything will be just within the square brackets. So it is the reason, again, if you want to understand more syntactically, you remember when I just gave 10, it was giving me Boolean outputs. So this syntax will literally apply the output of this expression on top of each and element. Whenever that condition becomes true, then only it is displaying the output. So that is the internal understanding of how this mechanism works behind the screens. Nevertheless, we'll move on to the only relevant ones to our electricals. Let's apply few statistical terms as well. Statistical methods. If I take this array itself as an example, you can apply mean, mode, median, and all of standard deviation, variance, all those things on top of this right away. So if you see here, let me try applying a dot min. So in this array, the minimum element is 1. So let me try applying max. It's very straightforward. It is a maximum number in this array. And let me try applying mean on top of it. So the mean value on top of all the elements of this array is 14.65. Again, you already know that how do we calculate mean? Sum of all these elements divided by total number of elements. So that's how you can apply. There are functions for each and everything. And if you want to get a look at list of functions available, as I always suggest, please go for W3 Schools, NumPy, Python NumPy. Very good resources with all the list of available functions. You do see that there are these many statistical, usually we use this for during our day-to-day life in machine learning model trainings, but for you, I don't think you will be needing this much trigonometric depth functions, but it is very easy to adapt. In my case, let us say I would like to do some NumPy functions on simple arithmetic. So you do see that np.add, np.subtract, and rounding of decimals or summations, truncating, fixing it, rounding it off to the previous integer, rounding it off to the next integer. So all that we need a takeaway from this session is it is not a difficult thing to adapt to these functions, and nobody asks you to remember all of these functions. It's just that if you know the syntax of how an array is built and how do we define a variable and how do we apply a function, you can just right away Google function name, what is the thing that you want to do. Now that it's a chat GPT era, so nobody cares whether you are reading it from the scratch or from the right away. So you just need to know when to apply what function, and if you have that smartness, NumPy is something not you can remember all the things that it exists. You just need to know the application of it. So that's how we do statistical on top of it. And yeah, there is standard deviation as well. Again, NumPy, no, yeah, great. Standard deviation. So this is the standard deviation value of that. All right. So on top of this, I guess we'll be done. There are set functions on top of this: intersection, union, difference. Those are all simple functions. I don't think we can waste time on that, but yeah. Okay, now I'll try to give an example. We'll take a question. So please look at this example. If you see here, I have an array which consists of strings, and I have another array which I am trying to generate random numbers which are going to be 7. So if you want to see the output of this, so what it is doing is random is a method module within the NumPy library. So random is going to generate random numbers which are 7 rows and 4 columns. If you see here, there are 7 rows and 4 columns. So if it is of 2 dimension, obviously it's a matrix, right? So you can see that it's a matrix. So the easiest way of generating array. So random is a method, again module, in which it is using rand_n method. So in this case, it is generating 7 rows and 4 columns. So if you see here, I have 7 names and I have 7 by 4 matrix. You can literally compare it like a table or a Google sheet or an Excel sheet. There are 7. This is like heading of the table which we have underscores. So for these many friends, these are the scores. So I'm trying to relate these two arrays right now. So what I want to do on top of this is just like a simple example analysis. What I want to do is I want to have only scores of, let's say, Bill. I want only the scores of Bill. So what I can do in this case is, if I try to compare it, there are 7 names and there are 7 arrays here. It means Tom row is this, Joy row is this, Bill is this. So for every name that we have in friends, there is one array row dedicated for it. So these are the scores of that particular person. Now what I'm asking you guys is, can you guys give me only the scores of Mr. Bill? So if you compare the positions here, the Bill scores are going to be somewhere this, right? This is the third name and this is the third row. How do I write a logic in such a way? I would like to access only Bill's scores. So that is exactly where we can use the syntax of how we applied this one. The same syntax as this. So what we will do is, I am expecting the scores of whenever the scores are equal to the Bill. So in my case, friend must be Bill, scores of Bill. So what I'll do is, friends is the array name that I dedicated, is equals to Tom, sorry, Bill in this case. Let me run this. I forgot to run this. You do see this? It is saying 0.78, and let me also run this guy. And let me run this guy. Yeah, you do see this. Bill is in third position. This is the row, and it gave us immediately that row. So it is comparing the scores column whenever friend is equals to Bill. So this is how you can apply conditions on top of another array. So again, these kind of concepts are more in data analysis levels, but for you to have an understanding in hands-on, this is how you can apply. So can you guys now tell what if I want to only access first 2 values? If you remember slicing concept, if I want to only access only first 2 values. So maybe you can give a try. I'll give for 10 seconds. If you wish, it's great. What if I want to access only first 2 values? You do remember that this is a matrix because it's a 2-dimensional array, and I'm trying to only access first 2 values. So if you remember my slicing concept, you need to give colon syntax for rows and then colon for columns. So how many rows in this case? Obviously 1 row here. And how many columns that I'm expecting is 2 columns. So all that you need to do is, this is how the slicing concept works, right? So on top of this, all the rows, in my case just 1 row, and I'm only expecting till second column. Starting is from the 0. So this is how you can access. Let me keep both of them for you. So this is the original one. What I did is I just applied all the rows, but starting from 0th column till second column. In this case, this is 0th column, first column, and second column. As you remember, second is nothing but an end value. End value gets always excluded, so it accesses it from 0 to 1. So this is how you can access slicing on top of arrays. So this is how you can apply on functions. Again, what if I want to access values which are only positive? One last question on this so that we can move on to next library. So can you tell me a logic where I can access only positive values out of this matrix? So how do we do that? Only positive values out of all of this matrix. If I right now do for scores, is displaying all the values. But if I'm expecting only positive values, you do remember whenever I want to apply a condition, start the square brackets and then go for the condition that you want to apply. As I'm expecting only positive, the mathematical logic behind that seems is greater than 0. So when we run this, you get a list of array of elements which are all positive from this scores. If you want negative, go for less than 0. If you have a specific condition, you need to write that condition here. This is how you apply conditions on top of arrays. So that must be good enough for you to have to understand the NumPy. Yeah, that's all about numerical Python and arrays, guys. So this must be good enough for you to understand what is an array and how do we apply NumPy things on top of electricals. All right, so now we're moving on to the next library, Pandas, which stands for panel datasets. Usually we use Pandas libraries whenever we want to deal with tables or CSV sheets. So in my case, what I will be showing you is all the data types that are then Pandas, and then how do we access a simple Excel sheet or a Google sheet or a simple table? How do we apply operations on top of that table? How do we apply mathematic terms on top of those tables? So this is how usually data analysis people also do it. So let me take an example URL for you guys to access it. A little bit of introduction about this Pandas will be here for your understanding. So Pandas stands for panel data, and it is a core library for data manipulation and data analysis, and it consists of single and multi-dimensional data structure and manipulations. So from Pandas, whatever it's necessary for our basic electricals are that we need to understand the data types involved in it. First thing is it consists of a data type called series, and it also consists of data frames. These are the data types, data structures involved within the library Pandas. It means you can define values in these two ways. So a collection of series becomes a data frame, and a series is nothing but a simple NumPy array in the previous library. The Pandas library is technically using and built on top of the basic library NumPy itself, guys. It's no different, but we will take few concepts of NumPy arrays even in Pandas. This is exactly why we started NumPy first. So let us take an example of series. So if you want a theory about it, I'm directly giving you the content here. A series is nothing but a one-dimensional labeled data structure which can hold all the items. So we can give it a read for it. All right, so now that we are into Pandas, how do we use Pandas related libraries and how do we use Pandas related functions? So as we imported the NumPy initially with import keyword, here also we are going to use import Pandas as is an alias name. You can give any letter you wish, anything you wish, but whenever you want to access Pandas, you can just do PD. This is how you import Pandas. And if I have to create a series, it means that it's nothing but a row, it's nothing but an array. So let me just give you a brief about it. What all we learned since our day one is we do understand that there is a list which is in this format. We do understand that now that we understood an array, which is a NumPy library, data type, data structure, And now we are going to pandas. So pandas technically consists of series and also data frame. So what are these things is a series again technically uses an array itself. So pandas library is used to deal with tables with multiple rows and multiple records. So one row is nothing but one series for us. It's nothing but an array. So one column is nothing but a column or a record for us, which is nothing but features in terms of data analysis. But one column is a feature. In this case, one series is nothing but one row value. So all the values in these can be defined in an array like this. So right now we are trying to define what is an array in under pandas library and what is the data frame. So we'll check that with a code snippet. Let me now try to create a simple series for you. A equals to PD. A is equals to is just like I am storing my series in some variable. PD is the name that I gave. Series, please be very careful with the case sensitivity. Series consists of capital S, not the small s. Because it's a method, you have to strictly follow the rule of it. Series of 1, 2, 3, 4. So it is nothing but basically I said it's a list or it's an array. So series is nothing but an n dimensional array, in this case a single dimensional array. So if you give an input like this, let us see how does it look like. You do see that it immediately frames a table kind of structure for us, which is obviously not in a good visualization. We don't have any boxes here, but a series, when you give it like this, it is generating just like a table. Zeroth row is 1, first row is having 2, second row is having 3, fourth row, third row is having 4. If you are confused with these numbers, let me give alphabets for it. You to see that these are the values that I gave and this is the indexing that it is following, just like an attendance register. So in this case, you don't want 0, 1, 2, 3 like this. You want something else customized. That is also possible. You can just take another parameter inside the function called series by mentioning it as index. Again, how do we remember all this? It's just a practice guys. Index is the most famous parameter that we use. So you can say I would like to have indexes like, let's say 5, 6, 7, 8. Why am I writing 4 numbers? Because there are only 4 values. So let me run this and check. So this is how it prints. You can have customized positions and customized values like this. So this is how you build a series. You can also build alternative way of building a series is with dictionary in Python. If you see here, this is a list data type. Rather than this, I can give a dictionary like this. You do remember that dictionary is nothing but a key value pair. So you can say, I don't need this index parameter as well here. I will just say, in this case, 5 needs to have A, 6 needs to have B, D needs to have C, sorry, 7 or 8, whatever. So if I try to run this, this also create a series, just another alternative, nothing changed. So you can either create with an input list like this, with an customized index like this, or with an dictionary format like this. So whatever value you give under keys, it will become your indexing. Whatever values that you give under values, it will become your values for the object. So again, this object is nothing but a data type. Basically everything is an object when it comes to internal data structure. So I don't think you need to worry about this object right now. All right, so that is how we do create a series. How do I create a random integer series is you can apply that random module which is there in the NumPy on top of this series. For example, I would like to have my data created randomly dot rand. If you want only integers, you can give int. Let's say I want 10 rows and 3 columns. Give me another parenthesis. Random numbers. Let me correct it. Rand int Python. You see that start and stop plus one. So in the W3 schools, so returns a number between 3 and 9, both included. So it randomly just gives a value between 3 and 9. So in my case, what I'm trying to generate is, let's say I would like to generate like this. So what I'm trying to do is it randomly generates a number between 1 to 10, which are 3 elements. So if you want 6 elements, you can give 6 elements. So in this case, it is randomly trying to generate 1, 2. Let's check the syntax again, 0, 4, 1. Both included. What I'm trying to generate is a matrix altogether. So let's try changing syntax. This is just a number between this, and if is, let us see if you can generate matrix. Of 5. So what is it generating right now is any random number between 1 to 10, which are 5 elements. So the mistake that we were doing was just giving another parenthesis in it. In this case, let's say I would generate 15 numbers. This is what we were expecting earlier on. So if I am expecting 20 to 20 to 30 is the range. Let's say we can tell, can you please give me 5 numbers between the range of 20 to 30? So 5 numbers between 20 to 30. So what is the usage of this is, right now I just created an array, but I want to convert this into a series. So our concept is about Pandas series. I would like to use this array as an input to my series. So what we will do is, as of now, I created an array by using random module from NumPy array concepts. So we will now create a series by giving data as an input to the series. You do remember that when we were initializing earlier on, so this is nothing but a list, or it can be an array, right? So we gave an input to the series and we generated series like this simultaneously. Similarly, I'm just giving a simple randomly generated array as an input to my series. So let us see what does it create for us. It will just generate a series based on the inputs that we have, right? So this is how you can generate a random number series on top of Pandas series. And if you ask me arithmetic calculations, let us try doing arithmetic calculations on top of this. Let me try to store this in a variable called f. This is my series right now. Let me try doing arithmetic calculations like this. So what it is going to do is it will generate another series by adding the element wise itself. So 25 plus 25 is 50, 28 plus 28 is 56, 28 plus 25 is 50, and so on. So you can apply any arithmetic operations on top of this. Can be subtraction, multiplication, division, exponent, square root, everything it will apply on element wise, guys. So I think this is something we already discussed in our NumPy array, so I don't think we can spend time more on top of that. Let's see what else we can do with series. So if you see this code snippet, what I'm trying to do is to randomly generate 15 numbers ranging from 1 to 15, and I'm converting that to a series called data1. Data1 is the value that I had it, and I'm giving a name to that table called scores. So if I go for data1, it will generate a list, a series like this. By default, obviously, it starts from 0 to 14. If you want customized things, just go back to my concept and use this parameter. You can have customized indexing. Right now, I'm not worried about my indexing, so I just left it empty. So it generated with the values that it generated from data1 array, and I gave that as an input to series function with a name called scores. So the name that I'm giving for this entire series is scores. If you want to rename it, you can just say rename, and then you can give your own customized names on top of this. So in my case, let's say I would like to rename it to dummy. It will rename our entire table to dummy. All right. So now let's move on to our data frame. What is a data frame? So in this case, if you see here, one row is one series. It's nothing but an array is what we just discussed. It is much more similar to our NumPy arrays concept. But now we will discuss about multiple rows and multiple columns, which is nothing but a data frame. So if you see an example or for a data frame, let me give you theoretical understanding of it. So a data frame is a collection of series like this. So a data frames are two-dimensional labeled data structure, consists of rows and columns, just like a table. And please remember, axis equal to 0. Whenever I use a parameter axis equal to 0, it means row. If I'm saying axis equals to 1, it means column. So please remember these two things, which will be useful in your next things. So now let me try to create data frame on top of this. The way to create data frame is, remember it's case sensitive. DA, TA, F or A. The capital is F is capital and D is capital. So what we are trying to do is create a table on top of this. So let's say we are just taking attendance and we would like to create two columns, student names and attendance, yes or no. So let us create a column using our dictionaries like this. Names is my column name for the table, and the students are this array of students. So array, let's say student 1, student 2, and student 3. So please try to understand this. This entire array, this entire list are nothing but student names. This is nothing but, in terms of Python, it's a value in a dictionary. And this is a key in the dictionary. Altogether, it is called as an item. It's a key value pair. So names becomes in data frame as a heading of the table, heading of the column, and this becomes the values of the rows. Let us see how does this look like right now. You see that visualization happening. This is exactly what Pandas libraries is taking care of you in your case. If you just give an input in terms of key value pairs, it generates a table like this with nice visualizations. If you click on some magic, you will also find, if you have, let's say, thousands of records, you can even decide how much to display. All right. So now we will run this again. I would like to create one more column to this. So in that way, I can just give, let's say, scores of the students. Another column. And then how many rows should be there? As I already gave 3 rows, this should also have 3 rows. Let's say 3, 4, 5. And run this. It will create another column called scores because that is your second key and all the values simultaneously with other rows. So this is how we can create a data frame. This is nothing but a data frame, which I said it's nothing but a table in our real time. But if you want to do some analysis on top of tables like this, data analysis, this is the way you can do. So let us move on and see what are all the capabilities of Pandas data frames. If I want to display the columns of this table, this specific table, you can have columns. So I did not name it, that's why. So let us give a name for this data frame. Let's say df is my name and run this. Now I saved my data frame. Let me run columns on top of it. So it will tell me that these are the existing columns in my table. All right. So this is how you get tables. Let me give you an example of multiple tables, multiple rows and multiple columns. If you see this example, this is trying to create a data frame, and this is my name. This is a column name for student 1, and then his score is 11. And then the same column, student 2, score is 12. The same column, student 3, the score is 13. So what is the difference? Is there is no difference. You can see this. Let me run this and also show you. See, in this case, we used a dictionary as key value pairs. In this case, I'm using list of dictionaries. You, if you love writing in this format, please stick to it if you had understood it already. I'm just showing you an alternative way of writing this. If you feel this is a little complex for you, you can just forget it, but this is not complex in terms of understanding. Me repeating multiple times this names, I just reduce it to one time. So this is just an alternative way of doing my table. Similarly, you can also create a table with series. So for example, if I have series like this, so what am I having? In this case, let me also write data 1 and data 2. So please try to understand these two snippets carefully. What I'm trying to do here is data 1, which is a variable having an array which is generated randomly from 1 to 10 range of 5 elements. Simultaneously data 2, which randomly generates 1 to 10 range of 5 elements. If you want to confirm it, just execute for data 1. Understand something is generated like this, and data 2, something is generated like this. So right now we have two arrays generated, data 1 and data 2. I gave data 1 as an input to one series function, data 2 as another series. Now we literally created two different series with some proper indexing. It's completely optional if you want to write it. If you don't want to write it, just leave it empty. It will become 0, 1, 2, 3. So now I just created two series. Let's confirm that again. This was array data structure. This is a series data structure. So now I need to use these two series as values of a table. So let me tell you what I mean to say here. I created series 1 and series 2, which consists of, let's say, 1 to 10 values and 1 to 10 values. I want to give these two series as an input to a table to construct like this. So imagine there are 10 rows and 10 rows. You just need to give a name for this table, just like A and B. So all of this is nothing but a series. All of this is nothing but a series in this case. So let's try to give a name to the column here. So what I'll do is a data frame creation. Data is equals to pd dot data frame. Now I already have series created. I just need to give names to the columns. So what I'll do here is take a dictionary object and give a name for the column. Key is nothing but a column name. Let's say shop 1, which has data 1 as values. So I'll just write data 1, comma, second column, shop 2, which has data 2 as inputs. So I'll just write data 2. And this dictionary is given as an input to the data frame, which is a method in a Pandas. So when I'm running for data, this is how it looks like. So if you see, this indexing was given in the series itself here, and shop 1 is my column name, shop 2 is another column name. All these data 1 inputs are arranged and organized like this. This is how we create a table using data frames in Pandas concepts. I hope you understood this. If you want to see the shapes and all, there are methods for it again. Just go for shape. It will tell you there are 5 rows and 2 columns. Let me run this and keep it as an example for you. So data dot shape gives you the shape of it, which is 5 rows and 2 columns. If you say data dot columns, it will give you a list of column names that you have in this table, which is nothing but shop 1 and shop 2. So now slicing concept is also used here. If you only want to access first 2 rows, you just need to write data is the data frame name, right? Yeah. So data of how many rows, how many columns. In my case, let's say I am expecting, uh, let's say only 3 rows, comma, all the columns. Let's cross check this index and then this index. When I'm actually accessing like this, it will even give you guys which column you want to access. Let us say I am accessing shop 1. It will give you the series values of shop 1. Let me also show you the slicing. If I'm expecting shop 2, this is my shop 2. What if I only want to access the first 3 records? In this case, you can just do, let's say, column 3, column 3. So the first 3 rows will be visible. This is how you can apply slicing on top of a data frame. So here also, if you say last 3 columns, you can complete. So these are the 2 columns, last from the last. So this is how you can access sub part of the tables. So slicing is always remaining same. It's just syntactically also it is remaining same. So I don't think you need to worry about it. So let me take an URL as an example for you. Please try to access this URL that I'm keeping in your Google chat, or you can refresh my page. You will get this. I'm trying to share you guys a URL which consists of a table. So please try to access that URL. It will immediately download a CSV file for you. And I want to see what is there in that CSV file. A CSV is nothing but an Excel sheet, right? So using Pandas, you can just do pd dot data frame. In this case, not data frame. In this case, I want to read the CSV. So read CSV is a method, and I will just paste the URL that we have and run this. This URL I pasted in your Google chat, guys. Please try to access it. Please use the method read CSV, which is from Pandas itself. When you apply this method with this URL in invited commas, please give it as a string. Invited commas, it will try to access this entire data set in your Google Colab itself. This is the advantage of using Google Colab and also the Pandas. So now for your example, uh, I want to see all the statistics and all the data, a summary related to this data set. You do see that there are 17,000 rows and 9 columns on top of this, right? So now let us say I would like to only access first 100 rows of this data. Just write, is there any variable that I stored here? Not yet. So let me give table1 as my variable name. So all this output will be stored under table1. So now let me use table1 dot head. It means first top If I mention a number here, top 100 rows. If I say 10, top 10 rows. If I say nothing, it is top 5 rows by default. You can check this. Let me run this first, and then it will understand what does the table 1 means. You do see that it is the first 5 rows from 0 to 4. If you are expecting 10 rows, give 10. It will give you access to first 10 rows. Simultaneously, you have tail also. You can use tail. It will give you tail. All right. So if you want some statistics on top of table, please go for describe method. It will give you all the mathematical statistics related to this entire table. So this is how you can play with Pandas library with respect to mathematical or with respect to the analysis. I think there are much more things that you can do with data analysis, but restricting for our electricals part, this is how you can apply this. Again, what if I want to access only latitude values? It means only this column. So table 1 is my name, and I am expecting output columns of only latitude. Just use the syntax latitude must be a string input to this function, not function, it is just a representation. You will get all the values related to that column. You do see that this is nothing but a series, guys. This is exactly why we learned series. One column is nothing but there it is generated as an output of series. So this is how you can access individual outputs of columns. Okay, so again, if you want to do slicing on top of it, it remains same. And if you want to do any mathematical operations on top of it, it remains same. Just go and apply df dot mean. It will be not df, in my case table 1. So in this case, these are all my columns that are there in my table. If you see here, if you want to list the column names, you can try table 1 dot columns. It will give you a list of columns available in that table. When I applied mean function on top of this entire table, it is telling me that for this column, this is the mean. For this column, this is the mean. For this column, this is, and so on. See, you can do these things with Excel sheet, but you do understand how much time and how much level of understanding and how much level of logic you need to write in terms of Excel sheets or other Google Sheets. But when it comes to Pandas library, you can just apply a simple function like this. It will take care of listing everything for you in this much clarity. So I hope you got a clear understanding of how a data frame look like and how can we access a table using this URLs and all that. So I think it's good time that we can move on to our most important library, which is a most awaited one, Matplotlib visualization library. Matplotlib visualization. This is another library. It's not your MATLAB. It is Matplotlib library. Again, competitors for this is Seaborn and Plotly, but let us see what can we do with Matplotlib. This is mathematical plotting library. You can draw graphs, you can draw pie charts or bar graphs. So any kind of visualization is possible with respect to a simple Matplotlib commands. So let me just show you how to import this. Import matplotlib dot pyplot is a name for it. So it is already showing me a suggestion. I'm just using that. So what I am doing it here is I'm importing mathematical plotting library, which is from pyplot, and plt is just my alias name. You can give your own names for this. So let me run this. Let us see what can we do with this. Let me randomly take a simple list 1 2 3 4 5, y as another list. Again, why did you even take this? See, as I'm speaking about graphs, You do know that we need to have x-axis and y-axis, right? So my x is going to be my x-axis and my y is going to be my y-axis variable. So this is nothing but a list of values, or it can be an array. This y is nothing but a list of values. So let's say in my case it is 1, 2, 3, 4 and 5, 6, 7, 8. Using Matplotlib library, I would like to plot x comma y coordinates by using this list. In my case, element wise, x value is 1 and y value is 5. So the matplot will plot 1 comma 5. In my case, this is 1 2 3 4 5 and 1 2 3 4 5. So 1 is this and 5 is this. So it will plot a point here like this based on the type of graph that you want to do. If you are expecting bar graph, it's a different scenario. If you are expecting a scatter plot, that's a different scenario. In my case, I'm just trying to plot it. So next is 2 comma 6. It will go on plot 2 comma 6. Next 7, 3 comma 7. Next 4 comma 8. Next and so on. So x is nothing but x coordinate values. Y is nothing but y coordinate values. So let us imagine that we already built a graph. So Matplotlib will also allow you to name this table, to name this graph as with a name for it. So you can give a name for it. You can also write x-axis name for it, and you can also write y-axis name for it. So what is that x-axis value? What is that y-axis value? What is the scale of it? What is the name of the table, graph? All of these things are possible with Matplotlib, guys. Let's take one example out of it. So as I said, x is nothing but a list of elements which are nothing but x coordinates. Y is nothing but y coordinates. So let me try to plot a simple graph. How does it plot this 1 comma 4 2 comma 5 and 3 over and so on? So let me just write plt is my name that I already used. Use a simple method plot. Plot is already there in your Matplotlib, and give x comma y as an input. So x is x-axis, y is y-axis. You can give your own names, no problem, but you have to remember that first parameter represents x-axis, second parameter represents y-axis. Just run this. Remember that it had started drawing a line based on the inputs that I give as per x and y here. So let us try to change values here. Let's say 50 and 16 and 7, so that we see something differently, not rather than a simple straight line. See here, 1 comma 4 is here, somewhere here. 2 comma 50 is here. 50 is here, 2 is here. 3 comma 16 is here. 4 comma 71 is here. 5 comma 8 is here. So comparing with x and y coordinates, the plot method is taking care of connecting these dots, connecting these coordinates. You don't need extra things or extra instructions to be given. Everything is already taken care by Matplotlib. You just need to give inputs. This is exactly why Python is too famous in terms of libraries. It's just a simple name plot. If you know it, just give inputs, it will do that task for you. So now it's very great. What if I want to give some naming to x-axis? You can give something here, plt dot x label, which represents x-axis. It means you are labeling the x-axis. Let's say this is stocks, and run this. You do see that it gives a name called stocks. If you also want y label, let's copy this. Just make it y label. It means y-axis name. Let's say prices. So this is the x-axis name and this is a y-axis name. X label and y label are the methods you can use for naming the x-axis and y-axis. And if you want to avoid some warnings like this, plt dot show is a method you can apply. Again, that is not an error, guys. It is just a warning showing you that it gave an output from so and so method. If you want to ignore such warnings, just use method show. It will avoid those warnings. So it's as simple as that. Now, great. If you want to give a name for this entire graph, you can use plt dot title and give a name for it. Let's say it's stock pricing. and run it. So you can get to see that it's a name for stock pricing. Let me put it here. The position matters as well. So please don't keep X label or Y label or title after the plot. Before plotting only, you should give all these instructions. So give that instruction first, and then finally you can go for these two lines. So what is it doing now? X-axis is named as stocks, Y-axis as prices, and stock pricing as a table name. So this is how you draw a simple line connecting graph. So this is cool and great. What if I want to highlight my coordinates here? So that is exactly where you have to play with the parameters involved in plot library. What I'm just going to do here is I will use a parameter called marker to tell that I'm expecting a circle wherever there is a coordinate. So I'll just write O and run it. You do see that it generates a simple circle whenever there is a coordinate. Okay, maybe you want to have a change of color. Yes, why not? You give a color, let's say orange. It has to be string. You get all that graph in orange color. Whatever color if you wish, like, you can go for it. And again, what are the colors that you need to know and what are the other things you need to know? Always go back to your W3 schools. Very good source of information. Not NumPy. This time we go for Matplotlib. So these are the possible options you can have under parameters. You can have markers, lines, labels, grids, histograms, pie charts. In our case, we are trying to do colors, right? So markers is our concept. So I came here and you do see that, yeah, marker row is this. So if you want to say other alternatives, let me see where is the resources for it. Yeah, so lines style is dotted. So if you want to apply line style, here itself you can apply line style. In our case, you can go for available called dotted. So let us see the parameter dotted. In this case, I go for dotted. So your graph can have dotted output like this. Or if you want this line to be even more better, you can go for line width. You can give a, let's say, 3 pixels. It is going to be, thickened. If you give 30, it will be even. Yes, sir, it looks like. So it's all about playing with the parameters. So nothing logical much in this, but yeah, that's how I do it. I do have a beautiful graph with me, which is on same concept. Let me show you that. So what I'm doing here is I took X values, I took Y values, I gave an X label, I gave Y label, and I gave a title. In the plot method, I am actually giving X and Y. Marker O means you want coordinates to be in this format. Marker size means the size of the coordinate, and the color is nothing but the color of the graph, and the alpha means the transparency, guys. If you make it 0.8, it will become a little more darker. So it ranges from 0 to 1. So the darker it is, the better is the number. If you make it 5, it is 50% transparent. So alpha stands for transparency. Line width is again how much thick you want that line to be. Line style is if you want a dashed line or a dotted line. I think if you give for a dot, it's not there. Let's say dashed, only dashed. You get this. Yeah. So this is how you can play with the existing parameters. Again, there is not nothing much of logical things in this. It's just playing with the parameters. So this is how you can plot a simple straight line graph. What are the other graphs? Can we plot multiple graphs in one graph? How to save that image? Yeah, you can also save that image. There is a extra method to do that. I'll show that in a while. Okay, so you just need to apply dot save method to that. You can save these graphs as well. Before that, let me finish all the styles of graph, then we can go for saving image. So what I'm going to take is, I have taken three inputs, y, z, and t. So y, z, t are my array numbers, array names here, and I want to plot these three graphs in one thing. Let us see how does it go. NumPy is just, if I am using NumPy anywhere in this, I can import it and use it. So I'm just applying plot y, plot z, plot t, because I want to apply multiple plots on single image. The more you want, the more plots you have to write. So in my case, I am using three things. So these are the three. Legend is something. Okay, I'll show. Let me first display this, then you will understand what is a legend. Legend is nothing but a simple box which represents this color belongs to that. So let me now ignore legend concept because you still didn't know this. So you do see that three different graphs on single plot. So what all I did is just took three different arrays and just plotted it. Right now I'm only giving one array, so it is giving me. If you want, you can give y comma z or z comma t with x and y coordinates. If you do not specify any coordinates in first parameter, by default x-axis will be considered from 0, 1, 2, 3, 10 like that. So in my case, if you see here, first one is yellow in color, or let's confirm this. This is a plot from 1. So y is 1. It starts from here in this way, right? So 0 comma 1 is what it considered. 1 is in y-axis, 0 is default value considered because you did not specify x-axis in this. So it immediately considered default value of x as 0, y has 1 in it. So it started plotting from 0 as x-axis, 1 from y-axis. So if you don't specify, it will consider as 1, 2, 3, 4, 5, and so on. All right, so this is how you can plot multiple things. Now let us see what does this legend mean. Let us run this. The legend means this specific box. It will tell you which color represents which graph. So this minimum, maximum, average, I gave them as labels while plotting the graph. So minimum is this graph, which is in color blue. So blue color is minimum, orange is maximum, average is green. This is how you can plot multiple graphs. In this case, it is plotted from bottom right. You can also change the direction like this. Let's say upper right in this case, and run it. It comes on top. If you want upper left, it comes on left. It's totally our wish. The legend is a method. LOC is location. Upper left is a position. So you can specify whatever location you want. And there is one more thing called grid, which will display grid behind the graph. So grid will give you grids like this behind. It's just to make you understand accurately where that coordinate is located. So this is how grid is available. Or if you only want x-axis as grids, you can go for axis x. It will only enable x ones, only x-axis plots. If you want y-axis ones, you can only give y-axis ones like this. So you can decide it's horizontal or vertical. All right. So again, if you are rushing to save this image, you can just right click on it. It will immediately give you an options, copy image or save image. There is also alternative of saving this image. You can just write a method whenever, I mean, usually in my real time, we will be generating hundreds of graphs every day. So we cannot come and do this right click all the time. So we write a function where it will save this image and put it in a directory. So I don't think you will be needing it. But if you're desperate to save it, this is how we can save it. All right. So now subplots. I think it's there in your MATLAB. How do we draw subplots? Let me give an example. You see this? Plot 1, x and y coordinates are this. Plot 2, x and y coordinates are this. So subplot is a method that you can use. What does this mean is one row, two columns. So that concept is like this. If I'm expecting two graphs like this, so it is having one row and two columns. So 1 comma 2 means one row, two columns. So you'll get two graphs. What if I write 3 by 3? It means three graphs row wise and three column wise. It will generate subplots like this, just like in your usual MATLAB. All right. So what if I say 2 comma 5? It will generate two rows graphs on five columns like this. These are the five different graphs. But each plot will have different x value and y value, right? That is exactly what we have to take it. X and y is for plot 1, subplot position under first row, second column, first position. So let me run it and show you first. So one row, two columns, and the position of this xy is first position. That is why it is this position. This 2 means second position inside first row and one row and two columns. So if I do one more thing with 1 comma 2 comma 3, it will generate one more. For example, if I want one more graph here, so what will be the logic now? I'll copy this and paste it here. This is going to be plot 3. Let it be the same x and y. So this time I'll be expecting 3 columns and the position will become third because second is already there. And we write it. Overlapping. So it is saying that you already have the same graph, so we don't need. So let's change it with some values. Matplotlib warning, auto removal of overlapping plot records. Let us say x and y, something like this. Okay, this is printing in the same thing, that's why. Subplot in Matplotlib. So this is our xy and this is our xy. Subplot 2 comma 1 means two rows, one column is first one, and the third parameter is position 1 and position 2. So let's see where did we go for it. Let me copy paste the same content and come to our Jamboard collaborator and paste it. What if I want plot number 3? Let me copy paste the same plot number 3, and I'm saying it has to be 3 rows, 1 column, and third position. This is exactly what we are facing early. So let us see where we are going wrong. 4. Mm, so 3 rows, first column, and if I don't mention it, 3 comma change in plot 1 and 2, 3 comma 1 comma 1. That we already have it, right? I see. We were not changing an other axis. That's why. Good catch. In the other way also, we were changing it. We did not do it, right? So let me write 1 comma 2 comma 3 1 1. We already have 3 1 1, right? And 3 1 2 and 3 1 3. This should fix it. Yes. So I got 3 rows and first one column, and the position of this particular subplot is first position because of this one, and the position of second plot is 2, so it is 2, and position of this plot is 3, so it is 3. So this is rows, this is columns, and this is the position of the graph. So yeah, this is how the subplots can be done. I think it's straightforward even in the W3 schools, but yeah. Let's go and see the other graphs along with line graphs, which will be interesting. I have a code for you guys for the simple scatter plot. This is my x and y, and the scatter is plt dot scatter is a method. This will not change anything else. I just imported Matplotlib again, and I just imported NumPy again, and I have x and y as an inputs. This time instead of plot method like previous one, this time I'm going to use scatter. Let us see how does scatter look like. Let me run this and scatter with x comma y. If I want to avoid warnings, you can go for plt dot show. So this will just plot the coordinates only, but if you want that connection to happen, go for plot method. So this is how the scatter will look like. Again, the same parameter. If you want to increase the size of this balls, or if you want some other colors, you can go for color parameter. If you want some other shape of the coordinate, unlike the circle, there are still parameters for it. So it's just a scatter plot in the W3 schools. You can go and play with the parameters involved in it. So let me just check this. If you see here, by default, he is using 2 graphs here. This is our first graph. This is our second graph. So first graph got a color called blue, second graph called orange. So if you are trying to plot 2 different plots in same graph, it will just change the color by default. You don't need to do that manually. So this is how you can plot 2 different metrics in one single graph. So this x and y are simple arrays, and scatter is just a method, and x and y are just an inputs to the scatter plot. All right. So let me take you to a beautiful graph that I have. If you see this should make sense to you. I imported libraries and I randomly asked x and y to be generated by randint, which is a random method in our NumPy. And then we applied colors. Again, this can be this colors variable is applied as an input to the parameters. Okay, so the scatter method consists of X and Y as an input to the arrays, and C is a parameter for changing of colors, S is for the sizes, alpha is a transparency. C map is the style of color that you want. You can either remove it by default, whatever it is, you can just remove it. And if you run this, it will just choose whatever default colors that you have. So this has to be your, basic understanding of scatter plot. All right. So moving on to bar graph. All right. Sorry. What I'm having right now here is x-axis is having ABCD and y-axis is having T8 110. So bar is a method that I can use here. Bar is a graph and XY are my inputs. Show is just to avoid the warnings. So it is just one method which will compare element wise. Under A category, this is a value of A. This is a B category under the value of B. So this is how you can plot bar graphs. So x-axis is nothing but the categories that you want to do. Of course, bar graph is about X and Y, which X can be any category and B can be the value, right? This is how we represent a bar graph mathematically. So it is as simple as this. There is nothing much complex about bar graphs. Or if you want to represent the same bar graph in horizontal wise, you just need to keep H here, which is a horizontal graph. So it will just display the bar graph in a horizontal basis. So I'll keep both for your practice. It is just a vertical graph and that is going to be a horizontal bar graph. You can also change colors here as well. Again, there is not much of logic involved in this, just usage of the parameters in this. If I say red, it becomes red. If I say height, it's bar h. It will let you know this gap. So if it is a normal bar graph, it will be width. Let me show you the difference. So in the normal bar graph, you can decide how much of the width of the each category that you want to have. If you say 0.5, it will have this much of. If you make it 0.2 again back, you can see that width of the each box becomes reduced. Okay, if you say 0.7, it becomes big. It is width when it is vertical like this, but when it becomes horizontal, it becomes height. That is the difference between width and height. All right. So that is with bar graph. What about histogram? You can also plot histogram graphs in this. So X is randomly generated. Instead of me taking burden of writing values in an array, I'm randomly generating normal distributed values by using normal method. Histogram is a method name. Hist is a method name. I'm just giving one input, and you already know that show is just a errors. So that's how we do histogram on this. So that's it, guys. The more you want to plot, it is just a method change in the Matplotlib. I think there is not much of logic involved in it. It's just one single method name that you have to change, and the entire visualizations will be changed.